Hi everybody and welcome back to the channel. In this video we're going to take a look at how to render a really high resolution, high quality image within Unreal Engine. Remember, the best way to support the channel is by hitting that like button, leaving me a comment, sharing this video around, subscribe if you haven't, and ring that bell for notifications. That really helps me out. Okay, so what you're looking here is the abandoned apartment from Quixel. If you want to get this project so you can follow along, you can always go here into the marketplace, always go to free content, then mega scans, and it should be this one right here. This content's totally free, so you can download it if you want to follow along. Now I have done a couple of modifications to this project, but the first thing you're going to need here, and it's super important, is to activate the registry variable that's called TDR delay. If you don't know what TDR delay, there's a link in the description below. You can go and watch my previous video on how to render a movie using Movie Render Queue that really goes into depth into how to install that, and I also go into depth into many of the settings if you wish to know how they all work. For here, I'm just going to go into the settings that are important to rendering high resolution image. Okay, now if you got all of those things ready, now what we're going to do is we are going to go into our sequences here in cinematics. As you can see, I'll only have the trailer. We're not going to use that. We're going to create our own sequence because this one has several animations that we actually don't need in order to just render one image. So what I'm going to do is I'm going to add a level sequence. I'm going to click here, and you can keep whatever name. I'm going to give it the name flowers, and it's going to be saved as an asset. Now you're going to get this little window right here after you accept that. What you need to do is go here into track. You can create your own camera if you want to. I'm just going to go here into track. I'm going to go actor to sequencer, and I'm going to write cine, and I'll just grab the camera of the same name that I have right here. So that'll be cine camera actor day 4. There you go. This is going to load the sequence right there for you. Now, the sequence, it's not doing actually anything. It's just a static camera looking at the same spot that the camera was looking at. So there's no animation and no extra motion. That's exactly what we need for this. Okay, now that we have our sequence, we need to open the Movie Render Queue. Even though this is called Movie Render Queue, we can use that for images. So I'm just going to go here into Windows, Cinematics, Movie Render Queue. Now the Movie Render Queue must have a sequence. So remember, you always have to go through this step first before you get into Movie Render Queue, because when we hit over here in order to render our image, it's going to ask us for a sequence. So I'm just going to click on flowers, which is the one that we have right here. And you're going to see that we have the name of the sequence, we have some settings that we're going to work on, and we have the output of where things are going to be saved. Now what we want to go is here into unsaved configurations. That means that I don't have a preset. So I'm just going to click here. And this is going to take me to a new window where I can determine the settings that I want for my image. So if you've seen my previous videos, you know that I don't like JPEG because that's a file is too compressed, especially if we want to deal with a high resolution image. So I'm just going to turn this off because these work as a toggle. And I'm just going to add a couple of things here. I'm just going to click here. And like I said, you can watch the video that's in the description if you want to know more in depth about all of these. But I'm just going to use the ones that are related to this tutorial. So I'm going to use PNG sequence. This is, like I said, always say, this is like the happy medium between compression and quality. So I'm just going to leave that over there. I'm also going to add an anti-aliasing. So over here in anti-aliasing, what we're going to be using is temporal sample count. So I'm just going to bump that up to 16. And we're also going to override the anti-aliasing because as you can see here in this warning, it says, if the product of temporal and spatial count is greater than the number of TAA samples, then the TAA is ineffective and you should consider overriding anti-aliasing. So that's exactly what we're gonna do. We're gonna leave this in none, and you can see that actually went away. Because this setting is in beta, we're not going to be touching all this so we can avoid some of the errors. By the way, for this project, I recommend that you are in 4.25 and higher. If you don't see movie render queue when you open window and cinematics, chances are you need to activate the plugin. This should be activated by default, but in case you don't have it, you can go here into settings, plugins, and over here we're gonna go into movie, and in the movie render pipeline, make sure you click on enable. And again, this is still in beta. Hopefully it gets released on the next Unreal version. All right, now that we have that out of the way, the next thing we need to look at is render warm-up count. I always leave that at default. That's usually fine. Engine warm-up count, there's a little bit of an animation and a little bit of particle effects. So adding the engine warm-up count doesn't increase your rendering times that much when you're doing a single image. So just to be safe, I'm just going to bump that into the same value that I have the render warm-up count. Now we're going to add the next one, which is going to be high resolution, exactly what we need. So for high resolution, you're going to see that we have a couple of variables here. So we have tile counts. The reason why we have tile counts is because this is going to be rendered in sort of tiles. So in order for a really high resolution image to be rendered in Unreal, the engine separates it into different tiles. This is because otherwise the memory of the GPU will be overloaded and we wouldn't be able to render anything. So that's why Unreal separates the images in tiles and then does the overlap. It needs to do the overlap, so you need to input a number here. Otherwise, you're going to see a seam in your image exactly where those tiles were created. And over here, I just have a little bit of a graphical representation of what I was talking about. So if I zoom in so you guys can see, this is what happens when Unreal renders in tiling mode. So as you can see, it's going to render this whole segment, then it's going to render this one, and this one. And then it's going to attempt to join them together, which is why we need to have an overlap of all the images. Otherwise, you're going to have a seam between them. So for this, I'm going to choose a tile of 4. You're gonna get a warning here. I'm gonna talk about it in a minute. We're gonna leave the texture sharpness bias alone, and we're going to do the overlap ratio. This is what I just mentioned, the amount of overlap that we're going to give this. I'm going to give it 0.1, which is usually what they all recommend on the Unreal documentation, and I've tested in several images and this value does just fine. However, if you start seeing a seam in your image, increasing this value will help. Overriding subsurface scattering, that means that if you wanted to get a higher value of subsurface scattering for your scene, you could do so over here. I'm not going to do that because it's not necessary. This final option right here is just for debugging purposes, so we're not going to touch that in this tutorial. However, let's go into this warning. So it says this will render 16 tiles, each with an individual resolution of this measurement right here. There will be a total of 16 renders per tick and 256 render per output. So you're going to see when we start rendering that this will be the target for the rendering. It says large per tick sample counts may freeze the editor for long periods of time. So this is not going to be something that you click render and will be done instantly. It will take a little bit. For me, the one that we're going to do right now only took about a minute and a half, so it's not that long, but just so you know that your computer may act really slow while you're waiting. It also says down here that tiling does not support all rendering features like bloom, some screen space effects. Additionally, TAA and auto exposure are not supported and will be forced off. So this is the reason why I had to make some changes to this level. So let me put these things aside. And what we're gonna do is I'm going to take you to the level as it looks right now. So if I get out of my camera, you're gonna see that this is really blown out. The reason for that is because I disabled the post-process effect completely. So if I go here and search for the post-processing effect, and I go here, and we go all the way, it's just a little bit choppy. But you're gonna see that in the enable box, I unchecked it. So that means the post-processing effects, which was adding all sorts of goodies to the scene, is completely turned off because that had some bloom, that had some exposure that was interfering with my scene and was not going to render correctly. And that's why we have these instructions right here. So that's one of the reasons why I made those changes. So if you want to get what I'm getting and you're following along with this level, make sure you go into your post-process effect and disable it. Now, if you're not following along, you're just doing your own thing, all you have to remember is these instructions right here. So make sure that you do not have auto exposure. Make sure you do the manual exposure, and I'm going to go into the camera and show you how that's done. And you can also use exposure compensation. Okay, so after clicking over there, if you just want to go to your camera really quickly, just click the camera name right here, and that is going to take you into the properties detail of that specific camera. So now I'm going to show you the things that I changed. Most of these are done by default to the camera that was already placed by the person who built this level. What I did change was to make sure that there were no extra exposure that were not manual, and I also took out the bloom. So as you can see here in the bloom method, this wasn't like this before. I actually took the intensity all the way down to 0, so there's no bloom. In the exposure, actually I don't have any exposure compensation here. If you wanted to, you can do 1 that brightens the scene a little bit. Actually, I think that looks a lot better, so I'm going to leave it at that. So the warning that we have right here, what it says is that you can use the exposure compensation. So make sure you change this from auto exposure over here to manual. If you have it in auto exposure, you're going to see that everything is really dark. So make sure you change that to manual. And if you don't know the precise value that you want for the exposure that you want to get into this level, using the exposure compensation is actually very easy. All you have to do is play with the slider until you get something that you really like. In this case, I'm going to leave it at 1. I think that's fair enough. And that's pretty much the only value that I changed here on the camera. Now, after we've done that, it comes the good stuff. We're gonna go into our output, and over here you have the folder where this is going to be saved. If you click these 3 points, it's going to take you to a window browser, so you can select which folder you want. And around here is where we're going to decide what resolution do we want. For this particular tutorial, I decided to go completely insane, and we're going to do a 16K image. So I don't know what a 16K image is used for, but we're going to do it because we can. So 16K according to Google is 15360 by 8640. Okay, this is a 16K image, so it's going to be a huge image. Now over here, the things that I've checked, so override the existing output. I always check this in case I do more than one render. It always gets overridden and I don't have just a bunch of images lying there. The other thing that we need to change here is use custom playback range. So I'm going to tick this, and over here, the only thing that you have to do is choose something different than 0. And the reason why is because if you choose something that's 0, sometimes I've seen that it goes to -1. So if it goes to -1, it's going to render something that's out of your camera, and that's not something you want. So for this, I'm just going to choose 5 till 6. So pretty much we're rendering 1 frame. And that's it. Disable the tone curve. No, we don't want that. We want to use our tone curve. All right, so we are done. If you wish to save these settings, all you have to do is come here to presets and hit save as preset. This is going to save this as an asset in your project, which means that it will not be available in other projects. You have to create a new one or migrate this one to your other project. So I'm just going to write high res flowers here. Click save, and that's going to be my preset for this project. I can click accept, and now we are going to go into the rendering. So I'm going to do render local, which is going to render it in my machine without any programming or anything extra. All right, so I'm doing this as a separate recording. That is because if I record while this thing is rendering, it's going to crash because OBS uses the GPU as well as Unreal. I just wanted to show you the render preview. So don't freak out if you see something that's not right into your camera. This is just a low quality preview. You're probably going to be seeing something like this. I just wanted to talk about the things that you're going to see here on the render preview. So you have your current sequence with your name. You have the number of frames, which is 1. The elapsed time, in my case, was actually 1 minute for this one. Time remaining when you're rendering one image, mostly it's not going to show. It usually shows when you're rendering video. Pipeline state, it's going to say producing frames, and then it's going to say finalizing when it's almost done. In current camera cut, you're going to see here, cut name, we only have 1. Frame, we also only have 1. And subsample, you're going to see this number go all the way onto 256, like that warning was telling us it would do. So right now, current state, it's rendering, and it's going to say finalize when it's done, and this usually goes away instantly once it's done rendering. Okay, what you see on screen is good old Photoshop, and what I did is I loaded my image so you guys can see how big this is. So if I zoom out and I go into image size, you're going to see that if I switch this to pixels, it's actually as big as we wanted it to be. So this is pretty much 16K. And again, according to Google, I've never rendered at 16K. So hopefully this is what 16K is supposed to look like. And if we actually zoom in, you can see how far we go before this actually starts getting pixelated, and actually still looks good all the way up to here. So this is how close you can get into a 16 image resolution. And that was it, rendering a high resolution image. I know you may have some questions. One like, why did I go to so much trouble? Why didn't I went here and hit high resolution screenshot and do whatever multiplier I want? Well, the reason for that is because when you're doing high resolution screenshot, you are pretty much taking whatever resolution the viewport's doing. So if I were to take this, right now we're recording at 1080p. If I were to take this, this will be kind of tiny. So I'll have to multiply the resolution several times, and it will never give you something as accurate as what I showed you in Photoshop, because when you do a high screen resolution, you don't have the chance to tell it how many samples do you want this thing to be. You saw me that in my sequence, in my movie render queue settings, if I go to my anti-aliasing, right here I can control the amount of samples that I want this to have. So if I see that there's some jagged edges within my image and I wanted to zoom real close, I could increase this. You don't have that level of control when it comes to the high resolution screenshot that you get from the drop down right here. The other thing is, with the high resolution screenshot, we rendered a 16K image, something that if you're over here, I don't know how you would do that, but again, you have no control over how your final resolution is going to be. And if you go into the video that I did for the movie render queue, you know that there's a bunch of other options that you can override in here that will make your scene perform really badly, but it will increase the quality. So that means that it will render really good, but you won't have those settings within the viewport. So you can still move in the viewport nicely without having to go into all those trouble of cranking up the settings and then having a super slow experience. One final thing that I want to show you, and that goes into one of the reasons that I would not use a high resolution screenshot from here again unless I'm just doing some testing, is because I can also override certain things around here besides from the command variables. And again, that's in my other video. That was a very long discussion. Otherwise, this video is going to be like an hour long. So you have the game overrides right here. So as you can see here in rendering, we have texture streaming. So fully load, use textures. That means you're not going to be streaming textures. That means there's no texture pop-in if you have a big world that you're taking a picture of. Use LOD 0. So remember, when you have different LODs for all your items within the world or your asset, the further away you are from them, it usually chooses another LOD that's usually lower poly, and that will diminish the fidelity of your picture. The same is for disable HLODs and use high quality shadows. So again, for performance reasons, you may be using lower quality shadows so your viewport doesn't go all out of whack. But over here, you can just reuse that because it's not going to interfere. You can also scale up your shadow distance. Again, these are some things that we usually take into account when making a game or we're working in Unreal, so our computer doesn't go super slow, but you can increase the amount of shadows that go into the distance. Same thing for the shadow radius threshold. You can play with this. You can override the view distance scale if you have a lower view distance in case you needed that to increase performance. And you have the view distance scale right here. And I almost forgot the most important of all. If you don't have a high-end computer, you're probably working in a different scale of the engine. So right here in settings, engine scalability, you're gonna see that we have different types of quality that we can choose for different types of effects. Right now I have it in cinematics. I could actually move this down to high, and that would increase my performance within the viewport a lot. But if you wanted to have the highest quality possible when you're taking your picture, then you can choose cinematic quality setting while doing this, and that will automatically set everything to cinematic quality once it's rendering. Alright everybody, that is it for this video. Thanks everyone for watching. Remember to like, leave a comment with your questions. Let me know what you're using this for. And also let me know what other tutorials you'd like to see in the future. I'm always listening. Subscribe if you haven't, ring that bell for notification, and I'll see you in the next video.